Hello everyone. So in the previous lecture we looked at indoor air pollution in terms of cooking, more specifically the type of cooking fuel that was used. So we will continue on that part, but now we will look at the type of stove that is being used for cooking, and this can be different types of stoves. One is gas stove, then we have induction stove, electric stove and biomass stove. So as you can see on the right, there is an example of a gas stove. It's a cooking device that uses combustible gas, and this can be natural gas, propane, butane, liquefied petroleum gas, LPG, etc. as fuel. The most common pollutants from gas stoves are generally nitrogen dioxide, then carbon monoxide and formaldehyde. So gaseous pollutants. However, it can also release airborne particles such as PM2.5. So together with these gaseous pollutants and PM2.5, both are sort of respiratory irritants, and so a gas stove can emit gaseous pollutants as well as the particulate matter. Interestingly, it was found in a study in 53 homes that even when the gas stoves were switched off, methane leaks were detected. So it could be natural leakage, but it was a very interesting outcome that even when the stoves were not being used, there was some methane emissions occurring. Then the next type of stove is induction stove. This is primarily a cooking appliance that heats up through electromagnetic radiation. So it does not require any external heating element. So this is an example of the induction stove. In one of the pilot studies, it was found that if one switches from gas stoves to induction stoves, there is a 35% decline in nitrogen dioxide reduction. So of course, gas stoves require heating of natural gas uh, or similar gases, which will emit NO2 or even other oxides. So this were reduced in the induction stove. It was also found that there was a reduction in the average carbon monoxide concentrations, probably because we do not have an incomplete combustion of a fuel occurring in the induction stove. So in general, it was found that induction stoves are probably a bit cleaner than the gas stove. In apartments which were observed for a 10-month period, same kind of observations, induction stoves had 35% drop in nitrogen dioxide concentrations. In the same 10-month period, again it was found that the carbon monoxide concentrations were reduced, as we saw in the previous slide, compared to the houses where they had a gas stove, and the reduction was almost 50%, a bit less than 50%, but a substantial amount of reduction was observed also in the carbon monoxide emissions. So then in another study, in this study there were 6 apartments, 3 were with gas stoves and 3 were with induction stoves, and in all the houses it was found that on an average the gas stoves led to a indoor and nitrogen dioxide concentration achieving 197 ppb, whereas when you had induction stoves the average concentration was only 14 ppb, which means there was almost a 14 times reduction when the type of stove was switched from gas to induction. So that's a substantial amount of reduction by switching of stoves only. So it is clear that between gas and induction, in terms of the indoor air quality, the inductions would be performing better. The third type of stove is electric stove. So here we have an example of an electric stove. These are the stoves that contain one or more heating elements, usually made of copper. So we can see like copper coil is there, and when you pass electricity through these heating elements, heat is generated, which is then used for cooking. So while cooking with electric stove, one can still release the pollutants, but again, as in the induction stove, the amount of emissions are quite small when compared to gas-based stove. And again, one may think this is related to the burning of carbon-based fuel in the gas stove versus electromagnetic radiation or electric current in the electric stove. So it was again found that under control conditions, steady conditions, gas cooking would produce almost 2 times as much as PM 2.5 as the electric stove. So again, it's much more environmental or emission friendly than electric stove is much more emission friendly than the gas stove. And here in homes with gas stoves, they had 50% to 400% higher levels of NO2 than electric stove. So 50% higher means 1.5 times higher NO2 than electric stoves, and 400% higher would mean 5 times more NO2 with as compared to the electric stove. So as we saw in the induction stove, even with the electric stove, there are very uh, fewer emissions of particulate matter as well as of nitrogen dioxide. Then the next part is the biomass stove. So we have seen gas, cooking and induction, and then the biomass stoves are those which basically would use wood, charcoal and things such as cow dung cake for fuels. And on the right there is an example. Now the nature of the fuel and the general conditions in which these cooking occurs would mean that there are higher emissions of carbon monoxide and particulate matter, and thus it is generally said that biomass stoves should be used when there is adequate ventilation, because generally these are one either enclosed areas, maybe some kacha houses there, even in semi-enclosed areas, just because the fuel is such and the control is not that much that the immediate surrounding and a little bit more than immediate surroundings, there would be higher emissions or higher concentrations of carbon monoxide and the other pollutants, and therefore higher exposure as well. Thus, it is required that one should have adequate or a lot of ventilation, so that more fresh outdoor air is basically flushing the indoor air away and the exposure can be reduced. The way biomass combustion works is, first there is a gasification step in the uh, constrained amount of oxygen. So that's mu less than 1. So basically your biomass gets converted to combustible gases, and then the second stage we have adequate oxidation, maybe not so much that everything is converted to CO2, we still have CO, and generally flue gas will have CO2, H2O, and then again methane might be there, nitrogen oxides will be there, and these gases are the ones that some of them would lead to, well, we will be exposed to all of those gases, and then some of them will lead to more harmful exposure than the others. In terms of emission factors, basically the mass of pollutant emitted per mass of the biomass fuel that is burned. In one study, they were determined for carbon monoxide, methane, and NOx, and it was found that during charcoal combustion, CO emissions were 17.56 kilogram per ton of fuel. For wood combustion, they were 11.3 kilograms per ton. For methane, 0.89 kilograms per ton for charcoal combustion, and 0.46 kilograms per ton for wood combustion, and for NOx 0.17 for charcoal and 0.19 for wood. So generally it seems that charcoal is a little bit higher emitting in terms of CO and CH4, but we should also consider this, that the emission factors themselves are dependent on the quality of the charcoal and also the quality and the type of wood being used. In terms of magnitude, order of magnitude, they are not very far from each other. It is equally possible that in some cases the cleaner charcoal will be emitting less. So it depends on the quality of the fuel being used, but the order of magnitude looks to be similar, and in this particular case charcoal had a little bit higher for some of the compounds. It was also found in another study that in homes with wooden stoves, indoor PM concentration were about 45 to 51 microgram per meter cube, which exceeded the 24-hour standard for PM 2.5 of WHO. So it's possible in where we have wooden stoves and the room conditions are such that do not allow for very frequent flushing or cleaning of the indoor air, that the air quality guideline may be exceeded. So we need to go for some other measures, maybe changing of stove or having some cleaning remedial measures, which we will cover. Then the other stoves are kerosene stoves. In developed countries, the kerosene stove use has generally declined because there is more electrification. So there will be more electric stoves and more induction stoves compared to kerosene stoves. But still, in developing countries, kerosene is still quite used for cooking and lighting purposes. It has been reported that this is generally predominant in the African continent and also in the Southeast Asian regions. There is a substantial kerosene use as well. It was found that in one of the studies of 154 communities and 31,490 individuals in China, India, South Africa and Tanzania, that at least 10% was kerosene use. So it is not major, but it is still substantial. It's useful to know that kerosene is often advocated as a cleaner alternative to solid fuels such as biomass and coal for cooking. Uh, so it's better than solid fuels. However, of course, kerosene using devices also emit substantial amounts of fine particulate carbon monoxide, nitrogen nitric oxides, and sulfur dioxide. So there is still quite a bit of emissions from kerosene use, although generally said that it is lower than the biomass or solid based fuels. Then, as in other fuels, kerosene use for cooking has also been shown to emit chemical compounds that will impair respiratory functions and also infectious illnesses, asthma and cancer. But this is not specific to kerosene. It's basically in this study it's for kerosene, but also for solid fuels and other types of fuels, depending on the emissions and the indoor air situation and the indoor exposure. It is possible that the exposure can be high. And as mentioned before as well, kerosene use does emit PM 2.5. So it's generally cleaner than biomass, but still is emitting particulate matter as well as gaseous pollutants. So now that we have looked at the different types of fuels and different types of stove for making or cooking purposes, the next question is how can we reduce the pollution and therefore the resulting exposure as well. It has been quite much shown that even simple additions such as adding a chimney or a smoke hood can reach to large reductions in 24-hour average kitchen pollutant concentrations. For example, in one study, there was solid fuel used without chimney and then solid fuel used with chimney or a smoke hood, and it was found that CO was reduced to 10 to 55 with an average reduction of 40% when the hood or a chimney was used. Similarly, for ethanol based stoves, it was found that if one uses a chimney or a smoke hood, the reductions can be 75 to 95 and average 82%. So that's a substantial reduction without changing anything. And these few things clearly show that even when the type of fuel is not changed and the stove for the cooking is not changed, just by adding a chimney or a smoke hood, which can be even more rudimentary in nature, do not have to be very sophisticated, one can already achieve 40 to 80% depending on the fuel, but we can already achieve substantial CO reductions and by extension other pollutant concentrations as well. Here again it is seen that and then the next thing is to replace the stove itself. So again, so traditional stove replacement with improved stoves or adding a chimney as mentioned just now can result in 87% reduction in ammonia concentration. So that's again a very high reduction in ammonia concentrations, and also a reduction in black carbon concentrations, again 40%. So we are quickly seeing that just more efficient stoves or even some simple devices can substantially reduce the emissions and therefore the resulting exposure. It has been found that in household cooking using biomass exposure, the concentrations can be 500 to 2000. But when people use a cleaner fuel, which is maybe gas or kerosene, as compared to the solid, there is a much lower 24-hour average, 82 to 39, depending on foods, depending on the fuel. So it's basically 5 to almost 80, 50 to 80 times exposure reduction. So that's quite a lot of reduction just by switching the fuel. So that's another important intervention that is possible. It was although found that on a short term, so in this case cooking for half an hour, gas stove could raise indoor NO2 levels to twice the safe limits. But it's important to note that this is a small term emission. Once you average 24-hour exposure, this may go lower than the safety limit as well. So depends on how much the exposure duration is and what is the simultaneous guidelines of of WHO or any authority. Is it half 1 hour or is it 24-hour exposure? So now we have seen the types of fuel, the stove and the emission strategies. The next thing is the ingredients and type of cuisine themselves may be impacting. So here it is shown that cooking fatty foods may produce higher particulate emissions than vegetables, for example, mainly in terms of mass concentration, that is the mass of PM 2.5 per meter cube, mass of PM 10 per meter cube of air. Also it was found, so this is the type of food, then the particle emission factors also change depending on the type of oil used for cooking. So what kind of oil, olive oil or any other type of oil that is being used for frying or general cooking purposes. So that is one part. Then it was found that when we are grilling the food, gas stove were generating more particles than the electric stove. So that may be related to what was being grilled and also related to the type of stove that we are using. As we have seen earlier, electric stove probably can already reduce CO concentrations or emissions, by example, by 40%. So both the food and the stove are contributing. Same goes here, that emission factors from an electrical frying pan were well below those observed for frying using a gas stove. So again, the stove itself is there, electrical versus gas, and then probably also a contribution of type of oil being used. But in this case, if you have the same oil, then the changes are mostly related to the stove. But the take home is that the type of stove, the fuel, as well as what is being cooked is important. Then the next part is comparison of conditions where there is an exhaust and then where is no exhaust in frying conditions. So in a study in Norway, when it was found that even a frying of waffle can lead to PM10 concentrations in air. When it was compared to background levels of PM10, it was found that when the exhaust was on, the background concentrations were 19 times, the concentrations of PM10 were 19 times higher than the background levels. But when the exhaust was switched off, the concentrations were 62 times higher. So just by turning the exhaust from 62 times higher, we have reached 20 times higher. So almost 3 times or one third. We have reduced the concentrations to one third just by turning on an exhaust fan. Although when we are frying, the concentrations are going to be higher than the background. So again, exhaust does help. So we have looked at cooking so far. The next emission source we are going to look at is cleaning. So in a study in US, it was found that maybe average US adult can spend 20 to 30 minutes of cleaning their homes. On the side pictures, I have put some issues or some things that are more related to our conditions. So maybe these brooms are there, then bathroom cleaning products are there, and then of course vacuum cleaning is also there. Now the activities and the factors that emit that influence the effectiveness of cleaning, and of course the PM concentrations and the pollutant concentrations in air are dependent on which is the device being used. So is it a vacuum or a broom? The type of floor surface, is it a polished surface, granite, marble, or is it a carpet? And then what is the cleaning behavior of the person itself? How is the person cleaning the floor, for example? So it was found that vacuum cleaner can increase the particulate matter concentrations of air, and this can be two ways. One is when the vacuum motor is turning, some emissions may occur just because of this movement and some machine abrasion, and also from the resuspension of settled dust. Maybe the person is moving the vacuum on the floor, so the part which is below under the vacuum suction is being removed, but when we are moving on the floor, maybe the front part is being resuspended a bit. It was found again then the type of vacuum operation. Bagged operations released much more PM10 when compared to wet vacuums or washable filter bag vacuum operations. So that is also important. There was an increase in copper and elemental carbon content of particulate matter 10 PM10 during vacuuming, which suggests that because especially copper is being observed in PM10 content. So this gives backing to the notion that the motor action itself is leading to emissions of some dust particles. So emissions due to the action of the machine itself plus emissions when these are moving on the floor. So after vacuum cleaners, we have cleaning products. So cleaning products can use of cleaning products can result in different chemical compositions, emissions of different types of chemical compounds, including, for example, terpenes, chlorines, amines, and aldehydes. In fact, use of cleaning products has been identified as one of the major sources contributing to the volatile organic compounds in indoor samples in non-smoking homes. Of course, smoking homes are a very special condition in that a whole suite of contaminants are emitted. But for non-smoking homes, cleaning products can be a major source of volatile organic compounds, VOCs. So in fact also emissions from cleaning products, particularly terpenes, can react with ozone, which can infiltrate from outdoors, and the reaction of ozones with these volatile organic compounds can lead to the formation of secondary inorganic aerosols indoors. So we have the organic compounds, gaseous organic compounds, which react with ozone and form the secondary organic aerosols. It was found, for example, in residences in Edmonton, household products, which were mostly cleaning products, they accounted for 44% of the total VOCs detected indoors. So, VOCs can be emitted and can lead to secondary organic aerosols. And again, as with other pollutants, exposure and pollution of VOCs can be reduced by achieving a good ventilation. For example, if cleaning products are used in kitchen or in bathrooms, especially, the amount of ventilation is quite low. And sometimes if a person is cleaning, they can even smell different organic matter. Whether or not they are dangerous or how dangerous, that's another question. But the use of these cleaning products leads to production of VOC, and therefore increasing ventilation can generally help us reduce these levels of these compounds in the indoor air. So far we have seen sources through cooking and cleaning products. We will continue this as we go on in the next lectures.